Hey, is it Teams?
Hello?
Which link? Because I have
Teams,
KT
Teams.
in Google Meet link is what I've got.
No, no, no.
That's not the
No,
one.
no, no, no. Go to this one. Go to the Slack group.
The one shared at 4 p.m.
No, no, no. I just said it.
Just reload it. Okay.
Reload your Slack and you should have your link.
Correct.
So, okay. So there is already a documentation for workflow manager, which is already checked in inside our Anuvaad document 2022 documentation folder, if I'm not wrong. So that folder already has a file. So you can, I mean, basically you'll have to enrich the same file. That of course will have everything, but there might be a few things missing, right? Some changes, some say maybe API contracts and this and that. So all of that has to be added. Okay. Okay, cool. So what I was going to say is, yeah, so that documentation, so just use it, okay? Use it and you can start. So basically, both of you together can create the document, but Ratan, you will be owning that document, okay? So yeah, so of course, you can take help from Sri whenever required. All right. Cool. So Anuvaad, I think all the three of you know what Anuvaad is, right? So what Anuvaad does, just to brief out, Anuvaad is our translation is a language technology engine which can be used for multiple purposes. So translation is one use case, digitization is another use case, corpus creation is also another use case. So like that, there can be multiple use cases for Anuvaad, correct? So right now, the ones that we use in our pipeline are the translation and the digitization pipeline. Okay, so you can corpus creation also is done, but that makes use of aligner, which is about Anuvaad anyway, but it does not have a screen and all that. Okay, but you should build a screen tomorrow if you want, because right, even that can be a very good use case. No,
Is that data collection? The is that one?
no, no, no. Data collection is different. Data collection is an annotation flow. No. So here, corpus creation, as in you pass in. So basically, what does corpus creation do now? You take two txt files which has sentences, pass it to aligner, aligner aligns them and gives it back to you. But you can have like one more step ahead. So what you can do is instead of passing those txt files, you can actually pass PDFs. Let's say you have two PDFs. Okay, there is one Hindi PDF and one English. Hey, if you want, you can attend. So there is one English PDF and one Hindi PDF. Okay, you now you want to create a corpus out of it. So what you do, you just pass PDF, run it through digitization pipeline. Once digitization done, pass it to tokenizer. Tokenizer creates two files with tokenized value, JSON files. Those JSON files you pass it to aligner. Aligner will give you the response back. You got it. So that's what you can do. You can actually do a lot of corpus creation. Since we have digitization and tokenization, you can directly do it in aligner, right? So that is one more enhancement in Anuvaad. So apart from digitization and translation, think in that terms also, creating or making the corpus creation pipeline also live. Okay. Of course, it needs some changes because right now every job in via workflow manager takes only one file, but we might have to make some changes to pass two files. If you see workflow manager contract files is an array, so you can actually pass two files and then get it through the pipeline. Some tweakings are required, but think in those terms. Okay. So Pramod, you are aware of Anuvaad, right? So end to end. Cool. No problem. So now coming to workflow manager. Okay. So why workflow manager? First thing is there is Anuvaad is an event driven architecture. Okay. So that is important. So this is event driven and it runs on the architecture is on two patterns. One is async, another one is proxy. These are two design patterns. So Anuvaad runs on a combination of async and proxy. Since you have async and proxy, the proxy pattern is realized using a workflow manager, which is nothing but a centralized orchestrator. Okay. So you have an orchestrator. So orchestrator in itself is again a design pattern. Async because you have microservices and you have async communication, right? So you can actually start async jobs and you can also start sync jobs. Because of which Anuvaad two part is one is async, another one is proxy. Proxy, okay, so both of these are design patterns. So proxy is basically none of you are in Ulka, right? So you guys don't. So there is something called, so we did a thing in Ulka. So what we actually did is, it's a bit deviation from workflow manager, but this is something you guys should know. So let's say this is our NMT model, okay? Now what happens with NMT is you pass sentences to it and NMT gives you the translation. S1, S2, S3, S4. Okay. Now what happens is in NMT, the behavior is such that since it runs on a GPU, it's a very data intensive process. So you pass one sentence to it, it responds back in 1 second. And similarly, so this is 1 second, so you have 4 seconds, right? Come for 4 sentences of translation. But if you combine them, if you create like a batch of S1, S2, S3, and S4, the output time is going to be 3 seconds. Why? Because more the data, the GPU can trigger more parallel processes. So the GPU is going to be optimally utilized. That's why it's better to use batches in NMT. But of course, there is a limit on the batch. You can't have like a very huge batch that the GPU runs out of memory. So you should have an optimal amount of batch, which is like 75 sentences or something right now, right? So this is just a very top level explanation. So NMT behaves in such a way that when you send more data to it, its performance increases. When you send less data, the performance is very basic. So what we did is in Ulka, we have these models, right? So basically people can come to the Ulka platform and then access the models. So they can actually come and try this NMT model. Now what happens? Since there are multiple users and each user, okay, why are they using NMT? They are just using NMT to translate sentences. Suppose there are like 1,000 users, all of them are trying to translate. So you have 1,000 separate requests. So the latency increases, the throughput decreases, correct? The latency per request increases because you have 1,000 separate requests. Each of them is taking 1 second to respond. So that is a problem. Now, is there a way to fasten this? So what you do is instead of you getting 1,000 requests and hitting NMT parallelly, why can't you batch those 1,000 requests, create one batch of 1,000 and then hit NMT? So the NMT that used to take 1,000 seconds for, I mean, very rough calculations, 1,000 seconds for translating 1,000 sentences will now take only 900 seconds. You saved on 100 seconds of time, right? So you have to batch. So that's why we have something called as an NMT proxy. NMT proxy is a layer over NMT, which actually takes multiple requests. Okay. So these are the requests that is hitting. But when it goes from this to that, all these requests get passed into a single request. And then you hit the NMT. Once you get the response back, you divide that response and return it back to these guys. So now what is a proxy? Proxy is a layer over NMT. So that's how Zool also is. You know what a proxy is, right? Proxy is basically front end to the back end. Gateway. Yeah, it's like a fake back end to the front end, and it's like a fake front end to the back end. So for NMT, the client was the front end till now, but now this guy came into picture. So now for NMT, this is the front end. But is this actually a front end? No, this is also a service running on the server. That's why it is called as proxy. Proxy is a very standard design pattern in computer science. All event-driven architecture or any highly scalable systems are usually built using a proxy in order to load balance stuff, in order to maximize the utilization and all that. So that's why I explained this because I want to tell you what proxy is. Now, once you understand this, now you think of workflow manager. So instead of your client hitting every service, instead of that guy hitting, let's say it's a file has to be translated, the client should actually first go to file uploader, upload it, get the ID, hit the block merger, sorry, file converter if it's a non-PDF file, then get the output of the PDF, then use that PDF, hit block merger, get the output, hit tokenizer, get the output, hit translator, get the output, and then finally the file is translated. Although we have tools which have all of this, but without a proxy, without a pipeline which orchestrates this, the whole system becomes useless. You actually can't use it, right? That's exactly why we need an orchestrator. Why do we need an orchestrator? Because our pipeline is a pipeline of multiple tools. We have T1, T2, T3, and T4. These are multiple tools. And one operation on the pipeline is a job. A job does not get over until all of these are into play. And for that to happen, all of this is time consuming, right? So here, let's say it takes T1 time, here it takes T2 time, here it's T3 time. The total response time for the user is going to be T1 plus T2 plus T3 plus some delta, which is latency and stuff like that. So if this response time now, this if it increases say 10 seconds, what is the point of the user waiting? So you can't make it a sync process ever. So you have to make it an async process. If you have to make an async process, then all of these tools will become stateless. Stateless as in what it receives and what it gives out is independent of its module before it and after that, because it's async, right? So there's no contract as such. So you need a queue in between, so that these guys put onto the queue, these guys can receive from the queue. Yeah, so that is your Kafka queue, right? So now since you have tools which are operating in an async fashion through a messaging queue and not a REST API, you need workflow manager. Because the workflow manager is what manages the state of all of these guys. Because each of them cannot manage their own state, right? Basically, this guy will not wait for this guy to respond. So when will this guy know that this person has finished and I have to start picking? Because all of them are essentially stateless. That's what async means, right? So workflow manager is needed as an orchestrator, which orchestrates this entire pipeline. Is this clear? Is this clear? Cool. So this is the necessity of a workflow manager. Why did we write a workflow manager for Anuvaad? Is because of this. So these are the main design principles: event-driven, async, and proxy. Next, one more thing is configurability. Okay, event-driven, and I'll just write here. Then next part is it being configurability. Configurability as in let's say okay, let's say we have these 4 tools, right? T1, T2, 3, T4. Or let's do a bit more. Okay, so let's say that we had this. This is our Anuvaad system. Okay, this is our Anuvaad system, which initially was a monolith. Correct? Now, what do you mean by monolith? It had everything inside itself. It had the file uploader, file converter, OCR, translation, NER, PDF to image, PDF to HTML, all of that.
As one service.
Yes, all of them had one service, essentially one service. Although it was broken a bit, but if you looked it from outside, it looked like a single service, but with no configurability at all. Now the problem is this: if you do it this way, the only way this application can be used is as a translation engine. Correct? Apart from translation, you can't do anything here, because whatever goes in comes out as a translation directly, because all of them are executing in coherence, right? In a single system. So this system is not configurable. Why? Because here you can't do anything. Here you can't change this application to a digitization application. You can't change this to a corpus creation. You can't go plug this in and build subtitles out of it. You can't go plug this in and start translating documents.
Like those services can't be used as
individual services at all, right? So there is no configurability at all. That's exactly why you first break it into a microservice based platform, so that based on your requirement, you can only use T1, T2 if needed, or T2, T3 if needed, or T1, T2, T3 if needed, or T2, T3, T4, however you want. So now, yeah, using workflow codes. So now what happens is, now the system which was like this, which it had all functionality, everything was working, but it was very powerless. Now it suddenly became a lot more powerful, because now this system is not a normal application, it's a platform now. You can build products on top of it. You can build a digitization application on top of this. You can build a translation application on top of this. That's the reason why we had to convert it to this way. Okay, a monolith was then broken into a microservice. Once you have microservice, you have async. Since you have async, you need a Kafka queue. Once you have Kafka, all of these become async consumers, for which you need an orchestrator. And that's why we need workflow manager. Did you understand the context as to why all of this is needed? Okay. So now coming to workflow manager. So principally workflow manager is basically your orchestrating tool. So now you know that if you want to trigger anything, let's say you want to utilize the Anuvaad pipeline as a translation engine, what would you do? You would define something called as a workflow code. What is a workflow code? Workflow code is a configuration for workflow manager, through which workflow manager gets to know that these are the tools to be executed. First you do T1, then you execute T2, then you execute T3, and finally you respond back. If you just do it here, the workflow code is T1, T2, T3. You do it till here, it's called as T1, T2, T3, T4. You do it till here, it's T2, T3, T4, based on the number of tools being used. Okay. Now, So workflow man, that's how now you can have multiple flows into the system. You can have a digitization flow, you can have a translation flow, you can have a corpus creation, you can have a sentence translation or a document translation. You can have a paragraph translation. You can do split, you can do merge, you can do retranslate. All of that is possible because of workflow manager. If there was no workflow manager, none of that could have been happened. I'll tell you why. Let's take a paragraph, okay? When you translate a paragraph, you just get a normal paragraph and you translate it, right? You take a paragraph, go to tokenizer and get it tokenized, get it translated and respond back with the translation. Is that fine? But now there is something which is equivalent to a paragraph but does not behave this way. That example is merge. Take two sentences and merge them. Now it become a paragraph. Will you directly do this? You can't, because it's a part of a document, which means it has its own block ID. Now that whole block has to be retranslated. So you again come here, you get your block ID. We're using that now this is where it recognizes. You have a block ID. Based on the block ID, you do your tokenization. Based on tokenization, you do your translation. Similarly, when it comes to a sentence, you don't need tokenization. You go to directly go to translate. So as he said, right, the fact that each of these modules can be individually used is what makes Anuvaad so configurable, because it's configurable. So the system can be used as in how you require. It's like a plug and play type of system. Okay. So now since I mentioned all of this, so now with configurability, what did we do? What did we actually achieve? We actually made sure that Anuvaad now supports more features than it used to do before. Initially, we had only two features: a normal document translation, right? Or a say sentence translation. But now, since it is more configurable, you have more features. Now, once you have more features, you have to again come up with a definition for it. So we divided the list of features into two. One is called as a sync workflow, another one is called as a async workflow. Okay. So both of them are workflow types. Now, what is a sync workflow? What is an async workflow? So sync workflow is where you make REST APIs. Okay. Say for example, I want to translate a sentence. The sentence translation usually takes milliseconds, right? So the user can wait. You don't need to trigger a job, Kafka queue, register a job. All that's not required. So here is your client. Client makes a call to your pipeline. Let's say he has a sentence to translate, say S1. The S1 could directly first go to workflow manager. Workflow manager understands that this is a sentence to be translated, which means it goes into a sync workflow mode. As in, whichever module is required to be called for this translation to happen is called using a REST API instead of a Kafka queue. So that's what is called as a sync workflow. Sync workflow, your split and merge is example of sync. Your sentence translation is sync. Your paragraph translation is also sync. Only time when the process itself takes a lot of time, you trigger an async workflow. Which is that example? Your document translation, your sentence digitization, document digitization pipeline, right? Because they are long running process, the response time is too huge. Plus, not only response time, the system is blocked, right? Let's say I have so many API calls. All of these are live threads which are interdependent now. The output of this is dependent on this. The input of this is dependent on output of this. You have created a dependency. So all of these are blocked. That's why you have to come up with an async workflow for long running jobs. That's why you can scale it however you want. Tomorrow, let's say we have Anuvaad is developed for a throughput of 100 requests per second. That is our design. Now, let's say tomorrow, because of some reason, we have instead of 100, we receive 10,000. What would you do? You can vertically and horizontally scale this. If it was like this, you couldn't have done anything. You would have wasted a lot of resources. Of course, you would have supported it, but you would have wasted a lot of resources. Infra would be wasted. No, there is no point. No, because see, another thing is, let's say we have a request of 10,000 requests per second. If this is a use case, I realize that file converter and file uploader are working very fast. I don't have to scale this at all. No, I'll only scale block merger because I know this is the time consumer. So I'll save on my computation, my memory, my infrastructure, all of it. So this works very well because we can do selective scaling. And that also is supported through Workflow Manager, because Workflow Manager can now, Workflow Manager, since it behaves using Kafka, number of partitions and topics can be adjusted. So with Workflow Manager, even that is possible. Scaling assessment, that's how we scale these days, right? Even for bigger files, you have been able to support because of this. Okay, so async and these sync workflows. Another thing is this. Since you have a combination of async, proxy, and an orchestrator, since it's like an amalgamation of three, both of these are possible. You can do sync and async. Otherwise, you could have only done sync or async. So that's the one more advantage. Okay. So coming to the workflow configurations. So each workflow configuration has a format, right? There is a format in which you have to define a workflow configuration. Inside a workflow configuration, the workflow code has a specific format. The tools have a specific format. The way a Kafka partition has to be named. The variable of the Kafka, sorry, not Kafka partition, a Kafka topic. The name, a Kafka topic has to be named, and the variable to which a Kafka topic has to be attached. Even that has a specific format. So all of that has to be followed very well. Only then it will work. Otherwise, it won't. So please maintain those standards. Of course, there are enhancements and changes which I'll explain once I start sharing my screen and you go through the code. Okay. So that is it. And then, okay, so how does workflow manager start? So basically in workflow manager, we have two functions. One is a initiate function and another one is a manage function. Okay. Now, how does that work? We just imagine it as a state machine. Okay. S1, S2, S3. Okay. Now this is your request. Now this is your whole pipeline. This is our whole pipeline. Now first job is to initiate a workflow, which means the request first goes to S1. This happens through the initiate function. Once the workflow has been initiated, after that, S1 to S2, S2 to S3 is nothing but redundant, right? It's basically transaction between two states of the pipeline. So it is managed, it is done by a manage function. This happens through an initiate function, that happens through a manage function. So only two functions which run the entire workflow. Okay. So what these functions do, these functions will actually read the workflow. So when the workflow manager starts, it reads the configurations, the workflow configurations, stores it in a cache, and the cache is stored in multiple formats. As in, there is only one file that is read at the start. This is your workflow config. But when it is read, it is converted to multiple formats. One is a JSON file where all configurations are stored. Okay. Then there's a list where all workflow codes are stored. Then there's another, say, then it creates a map also. Now, why is this? Because once a request comes, first you have to check whether it is a valid workflow code or not. If it is not a valid workflow code, you just throw it right away. For that, you go to this list. You could have traversed this JSON also, but this JSON becomes very big. If you have more workflows, you have a bigger JSON. You have a bigger JSON, you have a parsing problem, right? You just have to go inside a key, inside a key, inside a key and check workflow. It makes no sense. So just do it once. Once the service starts, by the way, this is a YAML file. You are aware of YAML, right? All of you know what a YAML file is. You know what a YAML file is? Cool. So you have a YAML file. YAML can be easily converted to JSON because they are always interconvertible. YAML can be converted to a Java class, to a JSON, to a Python class, to a protobuf. It can be converted to anything. These days, YAML has a very good support. So you have a JSON file. Now, sorry, a JSON, right? Not a JSON file, but a JSON object. Now that JSON object has all configurations. This JSON object can parsed and we create a list of workflow codes. Whenever you start a initiate, first you check with the workflow code, and both of these are global variables. They are used across the session for once the system is up. So you get the workflow code, you check it against this list, whether that workflow code is there.
Is that the same JSON object which has all these language code, local A that we?
It's the same. So workflow code, you have this workflow code, right? WF underscore A underscore, what is that? FC PM PK TR, right? This is one workflow code. This is a part of this list. Like this, you'll have multiple. Okay. You'll have multiple workflow codes like that.
So yeah, so that list is iterated for the validation.
It is iterated for the value. So now whenever a request comes, you check in that list whether that workflow code is there or not. If it is there, it's a valid workflow. You go ahead. Otherwise, you don't. Okay. So yeah. So that is the configuration. And then, so this is how. This is why workflow manager is required and how it behaves, behaves in the pipeline. Now, next thing is the relationship between client and workflow manager. Okay. So now so as I initially said, if there is no workflow manager, if there is no orchestrator, then the client has to manually do a lot of things. The client has to talk to every other module, find out what is the input, what is the output, and then it has to make independent API calls or even Kafka. It has to put into the producer itself, right? So all of that mess can be reduced if you have a workflow manager. So now you will see why it is a proxy. You will have a workflow manager, and then this is our pipeline. Pipeline has FC, no, not FC, FU, no, uploader, converter, block merger, tokenizer, translator, NMT, and then you have content handler, etc., etc. There are too many services like this. Okay, there are a lot of them. Now, if you want, and all of them talk to each other through Kafka queue. Okay, so all of them are consumers and producers, and then you have Kafka queue. So now you have a client. Now this client is going to make a request. He has a document which is to be translated. Okay, now if this document has to be translated, it goes to workflow manager. Once workflow manager performs all its validation, it triggers a workflow. So the translation begins. Now, if this client wants to know what is the state of the workflow, if there was no workflow manager, how would client even know at what step is my service? It won't, right? It has to manage the state. It should know that the job, let's call it as J1, okay? Job ID J1. If there was no workflow manager, the client should maintain a state that J1 finished file uploader, J1 finished file converter, all of that. But since workflow manager is there, client has to do nothing of that sort. The client can just pass J1 to workflow manager, and workflow manager manages the state of the pipeline. So workflow manager knows which job is at which state, and every state has its own intermediate input and output formats. So that is also very well defined. Okay, you should keep that in mind. The Okay, I'll come to that later on. Just for now, just make a note that if workflow manager kind of remembers the whole state of the pipeline, so the client will always get the state information through workflow manager. Tomorrow you want to run some analysis and find out, oh, how much time is an average job taking? Let's say a translation job. How much time is it taking? You go to workflow manager. You want to know any type of information. Say, for example, what was the output of block merger for a particular type of file? Let's say I have I have a particular type of file. I know the category. Let's say I have school books or moral science textbooks or whatever. Now I want to know what has been the block merger output for them. What will I do? I, as a client, I have the category, right? The category. Based on the category, you filter out the jobs because you already have job ID, so you know jobs. With those jobs, you query workflow manager. You just make a search. Workflow manager returns with the entire response, and it's a list of JSON. Okay, like that, it has a list of JSONs for every job. Now, every job has a JSON where you have first, say, job ID. You have a job ID, then you have some metadata, then you have task details, which is an array.
This can be done on the Kibana.
No, you don't have to do it on Kibana. It's already there in the DB itself. Kibana is log. Kibana is different. Let's not go to Kibana for now. It's a logging mechanism. Here I'm talking about the DB that the workflow manager manages. So the workflow manager goes to its DB, gets the list of jobs. When it gets the list of jobs, this is the magnified view of every job detail. So you have job ID, you have some metadata, then you have task details. Every task detail is again a list which has details of every task. What are tasks? Each of these are tasks. So you go, you get the JSON of block merger, and that will have input, output, time, everything. So now you understood what is the power of workflow manager. Because of this, you can do any type of analysis you want to do on Anuvaad. You can get any information. Like suppose you have run a job that was like 2 years ago and you don't know what did block merger do with that. You can go find it in seconds. So that is why we need all of this.
So which is the database that workflow managers uses here?
MongoDB. It's a MongoDB where all of these are stored. Got it? So you can clearly find out, okay, so this was the output of block merger. For suppose you have like 100 jobs with you, you will have 100 block merger output, you sit and compare. Now think if workflow manager was not there, none of this would have been possible because there is no state maintenance. That's why, see, these principles are very important. That's why I stress on design patterns and principles, because if you stick by a principle, then you will understand how powerful it makes your system. Okay. So yeah, so that is one thing. So the workflow manager now acts as a proxy because these services don't even know that there is a client accessing them. What these services see is only the workflow manager. So they think that workflow manager is my client, but is workflow manager the actual client? No, the client is here. That's why this is a proxy. There is something called as a reverse proxy, the one that I explained, right? A fake front end to a back end is called as a reverse proxy. A fake server to a front end is called as a proxy. So here it acts as a reverse proxy in a way. Okay, so that is what workflow manager does. Now Kafka queue. So now what happens is, since workflow manager has to talk to multiple modules in a tool, tomorrow there can be multiple modules added or removed from the pipeline, right? Initially we had PDF to HTML, then one NER, and then some things. Now they are all removed. Block merger has replaced all of them, right? So now we suppose we want to remove block merger and come up with a pipeline with word detector and Google Vision. Even that is a possible. So adding a tool and removing a tool is very common in workflow manager because we keep on improvising, right? So whenever you want to add a tool and remove a tool, that also should be very simple. That's how you have to design the system so that anyone who wants to bring in a tool or take out a tool, it should be simple. Now, if you have to make it, then first thing that you have to do, you have to standardize. You have to standardize input and output formats. If you don't standardize it, workflow manager will have like a bunch of custom logic, right? Workflow manager will have nothing. So it will always know that, okay, this is to be done, that is to be done. So workflow, so that becomes very important. So now let's say that you now in order to avoid that that custom logic, you'll have to standardize, right? So now we have the standard feature. So what we have done is we have standardized the input output format at two levels. One is between client and workflow manager. Okay, this is client and workflow manager. This is one layer of communication between client and workflow manager. You will have an input, you will have an output. That is one contract, API contract. Next set of communication is between workflow manager and tools. This also has a specific input and this is an input output, which means any tool that gets added to the pipeline should always follow that standard. There is no way that you can just miss out on that standard. Is that clear? So this again is an API call, so should not be a problem. But this again is a Kafka call, right? So on the Kafka queue, the way you send the JSON, that is important. So these contacts are also there. Okay, so now you know. So yesterday we had this, right? Yesterday we had a situation where you had input output, right? The files array we had for when we wanted to add word detector and Google Vision to this.
Yeah.
Yeah. So I was asking you what is your output format and all of that. That is because I just wanted to make sure that the output format follows the format which all the other tools are following. So if this happens, then this becomes very easy. You can add any tool, you can remove any tool. Correct? Now, are these tools only accessible via Workflow Manager? No, these tools can also act as independent services. For that, it's the responsibility of these tools to do two things. One, expose API and expose a consumer which is in sync with the Workflow Manager contract. Also, write its own set of APIs which can be directly used by the client. Now, suppose I want to do tokenization, right? I don't want the pipeline at all. I just want tokenization. Either I can go through Workflow Manager or I can directly go to tokenization. The only reason why we wrote Workflow Manager is because we want it to be easier. We want it to be a pipeline based system and we want all the data to be managed at a single place. That's why we did it. But if these services want to act as separate services, even that can be done. Suppose I want to convert this tokenization into a library. Let's say I want to convert it to a library and I'll say Anuvaad tokenization.
It's done.
Yeah, right. So it can be done. It can be used by anyone. Anyone who wants to do tokenization can just import it and tokenize. Right. Like how we have yesterday we spoke of stemmers, right?
Yes.
Yeah. So stemmers are all libraries. Pandas is a library. WordNet is a library. Similarly, you can just build a tokenization library. We also have a plugin, by the way. You know that, right? Anuvaad is also a Google plugin.
Yes.
Yeah. Why? How was that possible? It was possible because of this whole pipeline system.
A tokenizer is library.
Yeah, you told me. Yeah, true. So that's all. So you can make a library out of it. You can make a plugin, Google Chrome plugin out of it. You can make all of that because it's designed in such a way. And then, yeah, and there is a standard input output format also. Got it? So I think, so yeah, this is in terms of principle. So any doubts on workflow manager? I mean, you guys have already worked on Anuvaad. I'm sure you guys might have any doubts that you think that should have been there in workflow manager or any questions here? Because you guys have all worked on Anuvaad, so theory, I think you're all pretty clear. One of the bugs that we had was incompatible states. Okay, so that was an issue which we had in Anuvaad. That we initially I thought that it was a bug in the pipeline. Then I realized that it was a configuration problem. So what happens is this, okay? Tokenizer always expects a JSON file for it to process. File converter expects a PDF file or some other file, right, for it to process. Now, suppose you define a workflow where it says first you do file uploader, then you do tokenizer, then you do file converter, and then you do block merger. Now, will this workflow work? This workflow makes no sense at all. And when such workflows are defined, you get that incompatible states error. Okay. So since tokenizer is not able to understand what file upload is sending, and since file converter is not able to understand what tokenizer is sending, we used to throw out an incompatible states error. We used to say that you're trying to access an invalid workflow, or we could say, and in the message we used to say that this is an incompatible workflow, please retry.
But when you give such workflow code,
Yeah.
it will anyways go through that list of workflow codes. No?
Correct.
That
But
validation.
yeah, but this validation only validates the string. It does not validate the compatibility.
Okay.
Now, suppose someone has defined this workflow, okay? It is there in the configuration. How will that workflow code list know? The list already has this value. It just does a string match. But it will never do a compatibility match. It won't pick one workflow and see if this workflow is compatible steps or not. That will only happen when a live translation is going on. Okay? So such things have to be avoided. That is first thing. Second,
adding up those things in the.
Yeah, you should never add such workflows. These workflows which have incompatible steps. Got it? So that is one thing. And then one more thing is related to Kafka. This problem you will have wherever you use Kafka. So what happens is sometimes based on sometimes the Kafka setup is in such a way that whenever there is a consumer rebalance, as in when one of the consumers goes down, or there is some topic partition assignment, at that time the offset commit fails. If you have known Kafka, you would know what offset is. Just to give you a very short explanation, this is a Kafka queue, okay? This is address A1, A2, A3, A4, A5, A6. All of these are addresses. Okay, this is a Kafka queue and this is memory block. 1, 2, 3, 4, 5, 6 memory block. Consumer pushes a packet here. Sorry, producer pushes a packet here. The consumer reads from here. Correct? Once the consumer reads from here, let's say this is a Zookeeper instance. The consumer should commit an offset saying, I have read from A1. So A1 becomes free. No other consumer belonging to the same consumer group will again read from A1. Why? Because of this offset commit. If something is available at A2, this consumer reads from A2. You commit it here saying A2 has been read. So that's why, so this is C1, right? Let's say this is a consumer group which has C1, C2, C3. All of these three belong to the same consumer group. They will never read the same packet again. Understood? This is why offset commit is very important. Now what happens is sometimes this offset commit fails due to some problem. Okay, due to some consumer rebalance, it fails. When it fails, the same packet is being read multiple times. It will be read twice or thrice or 4 times until this offset commit works. Now, so what will happen? Let's say you have started a job. This is all Kafka based, right? File converter has pushed to the Kafka queue, block merger had read from the Kafka queue, but the offset commit failed. What will happen? The block merger will again read the same packet. So already the OCR for the document is done. It was pushed to the Kafka queue. It was read from the block merger. The OCR was done. The OCR pushed it to tokenizer. Tokenizer is reading. This is one flow. But since the offset commit failed, the block merger will reread the same file again. So the OCR will again start. The tokenizer will again start. Translation will again start. So what will happen? If this happens for some amount of time, The workflow manager will never know when this job ended. Technically, the job has already ended because in a normal flow, FU, FC, BM, TK, TR, CH, all are done. The state was also updated to completed. But before it could be completed, since the block manager started reading it again, the state again became in progress.
It shows in progress for the longest time.
It will show in progress for days together. Got it? So this is a problem. That's why what we did is we introduced. So this problem is there in Kafka. Okay. So this problem is there in setup. So you have to change the setup to make it work, but sometimes it doesn't work also.
We use a Redis thing tokenizer.
Exactly. So so that was the idea. So that was the idea which I gave Abhilash to add it in Redis. So basically we used a Redis queue here, and we use this Redis as a state management, not state management, but basically a cache, a temporary variable, which helps workflow manager to and also these tools to tell whether this packet was initially read or not. So what we did now is every job ID, every packet has job ID, right? So if block merger has already read that job ID, it will never read it again. Even if the offset commit fails, we are not worried. So in order to solve that problem, the Redis queue was introduced. Same is in Ulka also. Okay. So I mean, it was first done in Ulka. We experimented it in Ulka. It worked fine. Then it was moved to Anuvaad also. Okay. So that is another problem in workflow manager. I mean, that we came across. That was mainly because of the Kafka queue. Logic wise, it's all working fine. It's pretty stable. I don't see any workflows breaking, right? I think translation, digitization, sync casing, everything is working perfectly fine. So logic wise, this is solid, no problem. But of course, there are enhancements to be done in the configuration, right? In the way configurations are written and in the way some part of the logic is written. I didn't get enough time to do it since I got busy with a lot of other projects, so did not get time. But yeah, once you guys take it up, you should be refactoring it. Okay, I'll also tell you what needs to be refactored. Okay, so I think this is with respect to how workflow manager operates, and then offset commits, workflow codes. Just thinking what else is pending. Do you guys think anything is pending? Is it just me or this guy adjusts the camera automatically? Are you observing that? This my laptop. I don't know if it's Steam or my laptop. Okay. See?
Yeah, it's detecting you.
Yeah, that's team.
See,
For us, we have the whole screen. I think only there.
yeah, for me the camera is actually moving, so I don't know if it is Teams or what, but anyway, that's a good feature. Okay, as long as you can see board, that should be good. So yeah, understood? Understood clearly?
Yeah.
All of you?
Yeah.
Other than sync?
Yeah.
Okay. So now we have to, do we have another chair?
I think this one.
No, it's okay. You pull or push?
Pull.
Okay, now let me share my screen and we can go through the code. Can you guys see my screen now?
Yeah.
Possible now. Okay. Abhishek, all clear? Let's go to Anuvaad Workflow Manager.
This
producer, consumer, there are no different as a server, different servers, no?
All of them are different microservices. All of them are Flask applications. This is one, this is one, this is one. All of these are multiple Flask applications. Every Flask application is a consumer, also a producer. Consumer to read from its predecessor, producer to its successor. Zookeeper, forget Zookeeper. Zookeeper and Kafka is one system. When I say Kafka, it has Zookeeper inside. You have no visibility to Zookeeper, so that you leave. Kafka is in itself means Kafka plus Zookeeper.
When we run it locally, we start different server.
Yep. Yes, you need to. That when you run locally, you need to. So let's start with configurations.
Yes.
I think that is already on. Okay, you can see my configuration, right? Take one example. This one. Okay. I'll go on explaining what everything is. Okay. First is workflow configs. Imagine this as a JSON file. Workflow configs is the key. Everything else that comes inside is a list. Each of these entries is a JSON object. Got it? This is how it gets converted when it gets converted to JSON. Now, workflow configs is your main key. Then you have workflow code. Now, when you have workflow code is what WF underscore A underscore AL. What does that stand for? WF stands for workflow. A stands for async. AL stands for aligner. Got it? Type async. It can be sync or async, right? Now you don't need type essentially. You can actually figure it out from A itself in the workflow code. So if you want, you can refactor that, like remove type and read it from there, make it more compact. But yeah, the logic depends on the type. Okay. In the code, we are checking. So if you change this, change there also. Description, just to make it human readable and tell them that what exactly this does. So it aligns the input file. Use case. What is use case? This is the prefix for the job ID of this workflow. Now we could have directly attached WF underscore A underscore AL only, but it just became huge because let's say you take a bigger workflow like our digitization. It is FC, WD, LD, BM, O15 GB, all of that. So it just becomes huge. So that's why use case is a key just to shorthand the workflow code and attach it to the job ID. If you want, you can remove that also. You can directly attach workflow code. So that's another thing that you can do. Then there is no. So for example, if you trigger a workflow, when you trigger a workflow, you need a job ID. For job ID is a 13-digit epoch where the suffix is a use case. It's for the job ID format. That's all.
You did a job ID, so it's starting on A underscore A. You would assume that that is a aligner job ID. And if it's something like Google Vision or something, you will get 015 GB like that.
Yeah, that is it. So looking at the job ID, you will get to know that what job this is. Then this is sequence. Sequence is sequence of steps. So first you have order. Sorry, you have order 0. In order 0, you have a tool. What is a tool? Aligner is the tool. What does it do? That is the description, and it's Kafka input output formats. What is the topic name and what is the partitions? Now here there is an optimization. Partitions per topic will not change. Partition per topic is a Zookeeper configuration, as in it's a setup level configuration. Okay. So once you set up a Kafka cluster, you decide how many partitions should be assigned to each topic, which means partition per topic is not even a parameter. It does not make sense because all topics will always have same number of partitions in a given Kafka cluster. That's how we set it up. Okay. So this parameter Kafka partitions per topic is not required.
Here, do we have any scenario of how many brokers are there and so on?
No, it's always brokers are different. Brokers are your servers. That doesn't matter here. That only matters when you're connecting to the Kafka queue. That is through your consumers. This is a configuration. Here it does not matter. Here, only thing that matters is this, the topic through which you have to push and the topic through which you have to read. So you can remove partitions also. You can just keep topic as a parameter and add some more parameters if you need. Then end state, whether this is the end state or not, that also. Now this also can be redundant because when you have order, when you already reach the end, you know that it is the end state, right? You don't need an end state key. So you can remove that also. Got it? That's why I said you can refactor this. You can actually refactor this. Okay. So this is one tool. Okay. Now, what if there are multiple tools? Okay. Just one sec. Even this has that key. Oh no, it does. I think there is a wrong.
I just opened Vision.
No, it's a commit. It's a commit ID. I just want to know why did it come. Okay, cool. Anyway, so now let's go for a workflow with two steps. See, everything is same. Order 0, order 1, everything else is same. Now, here there is one more refactoring that you can do. Now you see,
Here in the next two, the end state is false, so that it doesn't stop there.
it goes to the next step. But now, if you already know, if since you have order, if the order value, if let's say you have processing it, okay, we process based on the order number. If I say order number 3 and if it is not there, it means you have already reached the end state, right? End state equal to true is not even needed, so it becomes a redundant key. Now see here, see this workflow, okay? Then see this workflow. There is one thing that is common across both workflows. You know what is that?
Like
multiple single workflows.
Now this the FC tool is repeated here also, and it is repeated here also. Now why do we need it? Why can't we create a separate YAML file where we define only tools there? As in, we just write this much. There is a YAML file to which we only give this much. Name is while converter. This is the description. This is the Kafka input, Kafka output. For that, there should be one key. Now, when I define a workflow should be a list of that keys. That's all. I don't have to have a JSON, right? So that saves a lot of duplication, no? So this thing has been there in my mind since a very long time, but I haven't had time to refactor it. But this is one more refactoring. So when you guys document this, I want you guys to document these refactoring aspects, also the bugs that I mentioned. Okay, that has to be added. So this is how a configuration is written. I'll just show you one sync configuration also. Let's take this as an example. This is block translation. Okay. So basically you get a block and you just directly do a translation without tokenization if the user wants it. Then there is another, this is a plain translation. So if you see here, S stands for sync workflow, STR is the code. Sync workflow, sentence translation, description translates a sentence, same use case, sequence, order 0, first tool is translator. How do you talk to the translator now? You don't talk via the Kafka, you talk via the API. So you pass the API here. Got it? Now, if you pass an API, now see, that is the thing. The input topic, output topic, and the URL configurations comes from the config file. But the body which has to be pushed onto the Kafka queue, or the body that has to be sent in the request for this is there in the code. Okay, that also has to be refactored. I'll tell you how to do it. Now, say for example, take TKT here. You remember I told you about paragraph translation?
Yes.
So here, this guy first tokenizes, gets the output of tokenizer, passes it to translator. So this is a sync workflow of multiple steps. So both sync and async of multiple steps is supported. Clear? This is how the configuration is written. Now, these are API contracts. Kafka contract is the contract that goes on to the Kafka queue. See here, you see the request, right? This is the object. For a workflow initiate request, you need input, you need user details, and you need workflow code. You need to pass 3 keys. How do they look? I think I've checked it inside the code also. I'll show it to you. But I think this is a workflow manager. No, I think it is open in my pie chart. Yeah, it's there. Cool. Okay, so I think there is a models here. Yes, yeah. This is a workflow input. An example. This is a workflow code. These are the files. And you pass some user details. If you don't pass user details, it actually comes from the header. Both can be picked. This is how you get inside. This is how you initiate a workflow with file. So by the way, workflow always takes files as an input for async workflows. So files is always there. That's why the key says files. Output. This is the output. The output always has the input as to we, because we want to say to the user that this is what you had sent, so that it should not come on our side. Then you have output. Output, what does output say? Output is the final output of the workflow. If it is a digitization, the digitized file ID is the output. If it is translation, then the translated file ID or the work or the it's called as the file ID itself, which is a combination of job ID and a file. So file number. So that becomes your output for the translation. So like that, the final output of the workflow is passed inside the workflow object, output object. After that, end time, start time, job ID, and status, whether it is started, in progress, completed, all of that. I mean, one of them will be mentioned here. Then there is state. That state is not there anymore, but here the state that we have is this one, whether it is a tokenized, translated, or that based on the which tool that is at. Then there is task details. This is how every task detail is. What is its order? As in, was it executed first or was it executed second or last? Then what tool was it? What was the task ID? What was the input sent to this? What was the output received from this? What was the time taken for this task to end? So complete information of every task also is available in the output of workflow. Clear? Now you go to controller. So the controller, you have async initiate, first API, which initiates an async job. Then you have a sync initiate, which initiates a sync job. And then you have interrupt. If you want to stop a workflow in between, basically it stops, but it doesn't. So there is no graceful end here, because since it's an async workflow, we don't know how will you remove it from the queue, right? If you actually want to stop a job, you have to remove it from the queue. So this code has to be refactored. You have to make sure that when you call an interrupt, you should find a way for the workflow to stop, which is to be done.
But this interruption only stops
From the DB, it just creates an end. It just stops where it is.
next
Step will not
doesn't
exist.
go to the queue.
Yep, that's
Whatever there is in the queue, it's still
Hmm.
running. This has to be refactored in such a way that
the entire job stops.
whatever in the queue also should stop.
Stop. That is
It
the
should be removed from the
Kafka
topics.
queue, from the topics and the Kafka queue. Of course, there will be APIs, but you have to do some research.
Okay.
Then there is workflow job search bulk, as in you can search your jobs based on job ID, task ID, your user ID, etc. Mark inactive. These are those jobs which the user doesn't want to see on the screen in his inbox.
Mm.
You know, you have the delete button, no? You press delete, it just marks inactive, but the data is still there. We just mark it as inactive. Then this is config search. How? Because the UI should know, right? UI should give a drop down for them to choose which workflow they want, whether they want a digitization workflow or a translation workflow. For that, this is a search API which searches the configuration from the static file, the file that I just showed. Okay, so now let's say, okay, so this is controller. Then we have Kafka wrapper. First is your workflow manager consumer. The workflow manager consumer is the consumer. Okay, there are three consumers if you see. Workflow manager consumer, core consumer, and error consumer. Why there are three consumers? Because one is a core consumer, which is only used to initiate between, which means this consumer is an intra workflow manager consumer, as in it reads from the workflow manager producer only. So the workflow manager has a producer and a consumer in itself. The service itself has a producer in it and a consumer inside it. So the producer pushes and the core consumer listens to it. Next, workflow manager consumer is a consumer which reads from other modules. This FC, UFU, TK, TR, the output input of all is being read by workflow manager consumer. Error consumer is whenever there is an error. What if block merger failed? It posts an error. That error should come to a workflow manager. No, workflow manager should know that there is an error. So this is an error consumer which only reads for errors that is coming from the pipeline. Then there is a producer which actually produces when you want to initiate a job. Clear? Any doubt?
So these workflow manager, producer, and consumers are Kafka of individual microservices as well as the workflow manager.
So why workflow manager is a microservice.
Correct.
Inside that there is one producer and consumer. Yeah. So see, sometimes a single microservice. A single service can have multiple consumers and multiple producers inside it, or it can be just a consumer or a producer. It's like that. So workflow manager is connected to the Kafka in two ways. So this is a workflow manager service. Let's say we have a, let's say this is the workflow manager service. Okay. This is okay. This is our workflow manager service. This guy has two things inside it. One, there is a producer, one, there is a consumer connected again through Kafka. Same Kafka. There is no other Kafka instance. When a client initiates a job, the producer inside the workflow manager service picks that job, pushes it onto the Kafka queue. And then the consumer inside that will read from the queue and trigger a job. And now, so this is the initiate call. I said initiate somewhere, no? Initiate and manage. Yeah, the initiate, the first one initiate. This is the initiate flow. Post this consumer, the manage flow begins, where it goes through all services. And then there is another workflow manager. This is also workflow manager only. Same service, inside that there is another consumer. This is consumer C1, this is consumer C2. Now this is between these guys. Reads from here, pushes here, reads from here, pushes here.
Okay. The workflow manager of each microservice is pretty clear. But the workflow manager for the entire WFM that we have is only to get the info from the client and to provide the final result back to the client.
Yes.
That's it.
No, there are no multiple workflow managers. There is only one workflow manager which does everything. Okay. So this workflow manager receives from the client, takes a request from the client, reads it. Once it reads, now it has to initiate a workflow, right? Now it initiates a workflow through this. Got it? Now this is the initiate flow. Once this initiation is done, then the workflow has to be managed, right? As in it has to be pushed to multiple tools and received from multiple tools. That is done by a second consumer. Inside the same service, there are no two workflow manager services. C1, C2, and all of this is being registered into a database. The initiate result and the management result. And this data is again managed by workflow manager service itself, which is read by the client. Is that clear?
The interaction of those services with the Kafka is based on the topic they are subscribed.
Subscribe to. Yeah, they are basically pushing it.
Just one topic.
Multiple consumers inside the same service.
So that will write in the config of those each service.
Yeah. Okay. So cool. So that is your producer, and this is the producer and consumer.
So essentially, the main idea of the producer and consumer and workflow manager is just to maintain the queue of multiple clients coming in. And
Yeah, not queue of, yeah, of course, multiple client, multiple jobs. Through that comes from multiple clients. Yeah. By the way, I mean, one more thing, queue is only one, okay? Inside of the same queue, there are multiple flows happening. The queue, there is no multiple queues as such. Now you have workflow manager repository. So inside workflow manager repository, you basically have Mongo calls, insert, update, and delete, because MongoDB is what is used, right? Then you have workflow manager service. This is where the entire logic of workflow manager is written. Okay. First, you register a sync job. Basically, register a sync job as in it comes to this producer inside of workflow manager. It realizes that this is a sync job. So this whole Kafka thing is not even done. It takes a different alternate route of APIs and then executes it. Then you come to an async job. This function, again, this function actually is figures. I mean, this function is attached to the async API, right? So now this function pushes it to the producer. The producer figures it out that, okay, this is an async job. So it pushes onto the Kafka queue and that workflow is triggered. An async workflow is triggered. Interrupt job you leave. For now, it just creates an entry. Mark inactive also you leave. Then process sync. This function processes the alternate path, sync workflow path. Basically, go to the workflow configuration, read the tool that is to be executed, get the API from there. Once it gets the API from there, it gets a body which is there. So there is a folder called tools inside the code. That is where the body is prepared. I'll show it to you when I come there. So the body is picked from there. API is picked from the configuration and an API call is made. You get a response back. You again go to the configuration, check which is the next step, again hit it and get the response. Keep on doing it until you reach the last step. This is a sync workflow. Of course, in between you have validation and all of that. So that is pretty common, straightforward thing. And then validate tool response. The moment you receive a response from the tool, this is for sync workflow. Okay. So you need to know whether it has successfully executed or failed, right? So this is you check the tool response validation. You check whether it is failed or successful. If it is successful, you go to the next tool. If it is failed, you throw the error saying your workflow failed. Next, for get workflow details sync, as in this function actually builds an object for you to update to the workflow table. So whenever whenever one task executes, let's say you producer is post, the workflow consumer reads it and the job triggers now, goes to file converter, comes back. Now the output of file converter has to be registered somewhere, right? This is that function. This function actually takes the output of the file converter, converts it into the format that the workflow manager needs and inserts it into the DB. So then the work block merger is begun. So for every tool, the output of that tool is taken, converted and stored into the database. Then this is the function. This is the initiate workflow function, the one I spoke about. And then there is another function called manage workflow. These two functions are the one which actually run the whole workflow. Initiate is between these two, manage is between these two. I mean, these guys. So you initiate a function. First, you check what is the order of execution. Next, you take the first step details because it's initiate flow. Once you get the first step details, you get the input of that first tool. You first find out which is the tool. Then you got the input. Where will you get the input from? That tools folder. Again, the tools folder has the logic. You see the tools folder here, right? It has logic for all the modules. It is written separately because if you want to make any change, any enrichment, you can do it separately. That's why we're not combined it yet. Because at that time we had a lot of OCRs happening, 1.0, 1.5, 2.0, this and that. So we had to support separately. Otherwise, the idea was to have like a single interface of one bare bones object and then multiple class implementations, like how you have this abstract factory pattern, right? Like that, have like multiple class and then get the body. But since there was no surety amongst this whole OCR flow, we had to keep it separate. But you guys can refactor it. I'll come to that once I explain the tools folder. Okay. So through that tools folder, you get the input of the first tool and then you execute the first tool. Basically, you put it onto the Kafka queue. From here, now it goes to, from here it goes to this tool. Now this tool starts executing. Once it executes, it generates an output, either an error or a proper output. That output is read by managed workflow. Managed workflow reads it. If it is an error, it registers that error. If it is no error, if it is a proper output, then gets it, creates an object that is of the format of workflow manager, stores it into the database, and then triggers the next tool, which is block merger. So this is done by the block manage workflow function. So manage workflow keeps on executing unless the last step is reached. Once the last step is reached, the workflow ends. Clear?
Yes.
Then there is notifier. So we have this notifier function where we push the status, but that's a plan was to have like a socket based notifier, but we couldn't do it. Right now we just have like an email notifier or an SMS notifier for the job, but yeah, that is there. Then this is a utility function, get next step details. Basically when manage workflow executes, it needs the details of the next step, right? First step is executed. Now manage workflow needs to know what is the next tool, what is the next step. So this function is used in order to get the next step. Then update job details is basically a direct insertion to the database to update the job details. Whenever a tool is executed, you need to enrich the job details with the output of the new tool, right? So that is execute. Same get workflow async. As I said, the format, one is for sync and one is for async. We have kept it separate because we need the room to make any changes to both the workflow separately. If you have a single function, then it becomes very difficult for us to do it. Then this is get job details, as in this is our search API. Whenever user searches based on these criteria, job ID, workflow code, status, task detail, you should be able to return it. And then there is update errors, as in, so this is a function which is called by the error consumer. Whenever an error occurs in one of the tools, there are two ways. Either you directly propagate that error as your output in the output format, or you use our push error workflow function, which is available in the auditor library, the library that gives you log info, log error, log exception methods. The same library also gives you two more methods, push error and push error workflow. That push error workflow not only logs your error into the Kibana, but also pushes back to the workflow manager saying there has been an error here. If you use that function in block merger, the workflow manager gets to know that the block merger has failed. If it is in tokenizer, you will have to know that tokenizer has failed. So there are two ways of communicating the error. Either you communicate as an output of the tool or you communicate using the function. Both of them are depending on how you want to use it. So in the second way of communication, where you use the push error workflow method to communicate your error, the update error function is called through the error consumer. Clear? So this is the service logic. Let me go to utilities and then come to tools. So utilities is basically read all configs. I told you, right? Workflow codes are read and a list is created. All of that happens here. Then fetch output topics. The now output topics is also a part of the this thing only configuration. The workflow manager needs to know, right, which all topics should I read. So now if workflow manager knows which all tools are there in the system, then it will read the output of this. Right? If it doesn't know which tools are there alive now, so it won't know. So every time the workflow starts, we read the entire configuration to figure out which all workflows are defined. So we listen to output topics of only those tools. Same get tools of workflow, as in the JSON object, generate job ID, code for generating job ID, order of execution, and then get tool input async. So here what happens is manage workflow uses this function. So in manage workflow, first it goes to the configuration and finds out what is the next tool. Once it finds the next tool, if it is a sync workflow, you get a API to it, or you get a topic if it is async. That is your point of contact, either through a topic or a API. But you need the body also, no? The body that you have to push to the queue, the body that you have to send to the API request. That will come from this function, get tool input async. So if the current tool is this and the next tool is this, then this is what is going to be the input. So that comes from this if else block. This function that you see, right? It's a if it's a simple if else ladder. You can change it to a switch case if you want, but yeah, it's a very simple if else ladder. Not even if else, it's a if block. Is that clear? So you can see here. Workflow input is none, as in workflow input only comes when there is when it is in initiation stage. Otherwise, it is in the management stage. If it is none and you say current input is aligner, then you get the aligner input. If current tool is tokenizer, you get the tokenizer's input. If it is file converter, get file converter input. Got it? Like that, it happens for sync also. If it is aligner, get the sync input. Tokenizer, get the tokenizer input. And then yeah, input get tool input sync. Like how we have for async, we have a function for sync workflows also, which gives you the body of the input. Then call API is a utility which is used to call the APIs. And then there is get job details, normal search API. Then you have validator, which validates the input, whether this key is there, not that key is there, and all that. Simple validation which is there. Now coming to tools. Okay, let's take one example. Let's say okay, let's say this aligner is one tool, right? For that, we have defined a class where you can write all the logic related to aligner. Now, why have we, as I said, right, the actual implementation should be one interface and multiple multiple tools, or which is nothing but multiple classes, which all implement the same interface. So that whenever a change is done in the bare bones JSON, it should happen because that's the contract between all the modules, right? Following the same input output. But the reason why we didn't do it because at that time we didn't have clarity. At that time, these modules had different inputs. Like aligner takes two files as input, but block merger takes only one file. And OCR, there are multiple flows. One file output type, another flow has some other type of. In order to make sure that the pipeline still works, we created this tools folder so that whatever logic we add it here only. And once we bring everything to a streamlined state, then only this folder has to be changed. Everything else will start working. Understood? So whatever refactor you do, you do it here. So you change that implementation from a class-based implementation to a factory-based implementation. Like say, for example, Google Vision, right? This is the initial state. Suppose if the digitization 1.5 itself is the first state of the workflow, you get the output from, you get the input format from here. Otherwise, if it's a part of the workflow, then either block segmenter is its predecessor or word detector is its predecessor. Predecessor as in the state which is before this one. So in both the cases, you return an output of this format. That's all. So if you actually compare, the input output format is same across all services, just that you have to refactor it. And I think, yeah, then there is requirements.txt for all your libraries, whichever is required. So this is like a overview of the code and the logic. Now I won't be going through line by line. I want you guys to do it because if I go, then it will make no sense. I want you guys to go into it line by line and then come up with your doubts and questions, and please record them in your document and also discuss with me. So now I am sure that you guys understood workflow manager end to end, right? What it does, where it reads from, where is it, what is its logic, what it does. Pramod, all clear? Abhishek, you guys are main, so you both have to be understanding it properly. And then anyway, Python, you know, so should not be a problem. Repository, models, consumer controller, configs. Yeah, looks like this should be it. So any doubts, any questions based on this?
Not right now. Probably once I go through the code, start executing it, go line by line, I might have more queries at that point of time.
I'm just thinking if there is anything else that is missed out. Okay, sorry. One thing about yesterday. In yesterday's glossary, I told you that the algorithm runs for a fixed length of phrases, right? I think I didn't tell you why it is fixed length after that, correct?
Before you come back to that.
Yeah, I forgot, right? So basically now I'll tell you why it is fixed length is because so yesterday we did this search, right? Yesterday we had a list of phrases. Let's say this is our sentence. S1, S2, S3, S4, S5, S6. Then we did multiple computations. We did n square computations to find out which is the phrase. But now in reality, there is one more, there is a little bit more room for optimization. What is it? So that basically means that you know, okay, so whenever it comes to glossary or TMX, as I said, all of them have to be proper nouns. Okay. Now think of it. No matter what domain you are in, how long will be your phrase if you are only using proper nouns? Will it be more than 10 words?
No.
Supreme Court of India, that also it has off in between. Let's say there is a full form MBBS, MD, MS, or some PG, CMD, or whatever. How long can it be? It can be hardly 10 words, say 15 words, not more than that. So in that case, when you are comparing, you don't have to compare for phrases which are of length more than 15, right? 95% of phrases are of this category. So the false positives or false negatives are very less. Of course, I agree that there will be some big phrase, but there is no point of computing for them, and that doesn't fall into your 95% result set at all. That's why it does fixed length. So when it is computing, it checks first the hopping window goes from here to here, checks the length of this. If it is less than 15, only then does a search for this. Otherwise, it doesn't do.
Okay.
That is to eliminate the waste computations that we do, because we know that 90% of the phrases, not even 95, it's almost 100%. Phrases that come to TMX and glossary are all of length not less than 10. That's why now what happened? Since you did that, now this is not n square anymore. Now you have reduced it on a lot amount, right? Now if it is that much, if n square was your computation, and let's say your n, the size, or let's call it as m. If m, the number of words in your sentence was say 20, then you won't be making 20 square computations at all, because you'll only be making for checking for phrases where m or let's call it as mp, there is size of the phrase is less than or equal to 10. So now that reduced half of your computations, right? So that's like a practical, so that is an optimization done based on the data. So now you know, right, why you need more data to perform any type of optimization. It's because of this. Because even if you compute, then it makes no sense. You're just wasting your computation when you know that the phrase cannot exceed that much. So yeah, that was one thing that I had to tell you about yesterday. So kind of just link it. I'm just keeping it. So you have to add it in your document for glossary.
So currently it is 15, is it?
10.
10.
Make it 15, 20, however you want. Doesn't make much difference, because everything else is in place, right? Like hashing, Redis and all of that. So even if computation increase by a slight percent, still no
Is it
problem.
like hard coded 10?
No, it's a configuration. So it's part of the configuration variable. If you go to Anuvaad TMX, I think it's also there in glossary. I'm not sure. If it's not there, you add it in glossary. But TMX though, it's 100% what do you say, the configuration parameter. What else? Pramod, all good? Any doubts? Any questions? I think we'll be done anyway.
To stop the recording also, 8%.
Okay. And one more thing.
Yeah.
Right now you see these intermediate outputs, right? The intermediate outputs that you get in task details as the response of block merger and all of them are stored in shared storage. Okay. So they are not pushed to AWS and Azure Artifact. The point was to do it. We wanted to do it, but then I don't know why. Just got busy and I couldn't do it. So you guys do it. You remove it from shared storage and push it to AWS or Azure or whichever cloud storage you have. Anuvaad mostly runs on AWS. So you just take a S3 bucket, create a folder with the job ID, and then keep on pushing the files there and then delete it from shared storage. Right now, the link that we store in the database is from the shared storage, which gets deleted, right? After some time, we usually delete it saying that, it's not required anymore. Yeah, it's full and all that, right? So move it to shared storage and use the move it to cloud storage and use the link of the cloud storage into your DB. So that is one more thing. And you don't have to do, there is no coding to be done because Vulka already has a service called as file store. You should go to the configuration and you should say cloud storage to be used is AWS and pass your keys. It will take care of it, everything. You just have to plug it in. So once your files are done, you just make an API call with your file ID of this file path from the shared storage. File store will read it from there, take your credentials and upload it to AWS.
Eventually, whatever the files we are doing in shared storage, the download path will be connected to
AWS. That thing. And the once that download is complete, your shared storage path will be deleted so that your shared storage does not get full.
Okay.
That is the thing.
You don't have to manually go and delete it every time.
Yeah. So that is one more thing that we have to do. And one more thing.
Eventually, when reading from currently, these services are mapped out to each and every shared storage path. So when reading, each and every service has to be marked down to that S3 or some whatever the subscription.
No. For that, you use shared storage only. Once the process is complete, once the translation is complete, what is the point?
Okay, that file we are sending to.
Yeah,
Okay.
no, that file goes to content handler.
Shared storage is an intermediate kind
Yeah,
of.
yesterday you said for Dean.
So once the translation is done, the data goes to content handler.
Yes.
But the intermediate files that were generated are still lying on shared storage.
Yes.
So that you don't do. When you make a call to content handler and store it in MongoDB, all these intermediate files also should go to cloud storage. So and clear the shared storage completely. Because what is the point of that having, right? And one more change. Right now, all these files are not separate files. That is a problem in our thing. Okay. Once block merger generates a JSON file, tokenizer is enriching the same JSON file. Please don't do that. Create a copy of it. Because see, for analysis, right now what happens is you have block merger, no? Block merger takes PDF as input, generates a JSON file as output. Call it J1. Tokenizer takes this J1 as input. In the output, it should generate J2, right? A new JSON file, but it doesn't do that. What it does it does J1 dash. As in J1 only with some enriched value. That should not happen, no, because tokenizer is actually overriding the same file generated by block merger. If that is the case, then I'll never know what was block merger's independent output when I read this file. So block merger should generate J1. tokenizer should should read J1, create a copy of it, and then enrich the copy and then upload. So this should generate a JSON file J2.
Eventually, the original and the new one should be sent out.
Yeah, the original should be sent to the AWS store, calling it as the block merger output. The J2 should be sent to the block merger as the tokenizer output. Now what is happening? J1 only is getting enriched across all systems. So independently, we will never know what block merger did.
Yes.
Independently, we will never know what tokenizer did because you are all enriching the same file. Got it? So that change has to be done. And that's why what happens is if you do this change, the number of files will increase. Right now, there is only one file traveling. Now you'll have multiple files. If you have multiple files, the shared storage will run out. For that, you move to cloud storage.
Actually, saying we are getting multiple files at each
No.
level.
Huh.
Block merger takes the file and enriches that thing and throws out, makes a JSON and throws out with a new file. And that file is the previous one, which is there in the file counter 80. That file is also present there.
Exactly. So now once the entire job is done, that PDF, this JSON, this J2, all of them should go to cloud storage, and then all of them have to be deleted.
Got it.
Because see, workflow manager already knows, right? It already knows where these files are. So once the job is complete and you are making call to content handler, parallelly call another function which uploads all of these files to AWS.
Shared storage is used just to avoid going to the cloud
Every time. Yeah. So it is used as a hot storage. It should be used as a hot storage only.
But yeah, we can make those
Yeah.
changes.
So these changes that I've just said, please make a note of these things, and all of these have to be included in the documentation.
Eventually, when we are sending out the previous predecessor, the next version output, the file name should be passed through workflow. I mean, currently workflow will be giving only the present JSON file. So we need to pass another parameter and just say out this was the block merger output, take it out.
Yeah,
and send it out.
that's out. See, now what tokenizer receives is J1. Tokenizer receives the block merger output. But when it reads it and enriches the same file back. Don't do that. Read it, create a copy first on the shared storage, and then enrich that file. Keep the original as it is. So that way we'll have access to all intermediate outputs. Otherwise, we'll never know what it happens. So usually a lot of this problem used to happen. So we never knew what block merger did and what tokenizer did. Some sentences would vanish in the translation flow.
By debugging.
Yeah, you will never know,
Which
right?
service is throwing this error or
That you should know. That is the thing.
is it happening in tokenizer or block merger?
Clear?
Yes, got it.
Okay then.
And translator the other day. That issue is addressed. This service.
So eventually, file translator is the starting process there. You don't have any file converter there for documents. So eventually, when workflow calls file translator, I would know the documents means file translator is the first service and you have to look into that. There is no previous one.
If it is PDF, then
Yeah, if it is PDF, then we might want to look into
two reasons. Converter, translator.
what block merger. Eventually, inside block merger, we need to check. For digitization, we have.
So are we done?
Yes.
Anything else, Ratan?
I'll start executing this. I
Yeah.
believe I'll have more queries upon this.
Cool. So whatever your doubts, queries, everything, please get it cleared. Okay.
Sure.
Because once I move off, then it's going to be very tough because I don't know what is the work there, right? So if there's a lot of work there, then I won't be able to give any time here. So please make sure that you guys are independently able to handle any issues that come here.
So I've already made a copy and running the workflow thing in my local.
You need Redis, Mongo, and
Redis,
Kafka.
Mongo, Kafka. So all three things are up.
Just execute, go line by line. If there is any doubt in any line of the code, let me know.
I'm just about to start with the Kafka. How the processor event is going on.
Okay.
So we'll take it out.
Sure. So Pramod, did you speak to Amit?
No, we have a meeting tomorrow. We have scheduled a meeting.
Why tomorrow? Why not today?
This one.
No, no, I'm not talking about KT. Like, did you decide which modules will you take?
No.
Not yet. Why Amit is not there today?
He's in,
Okay.
give the KT to respective both of them.
No, you will give KT for OCR, right?
OCR.
He'll come. Amit will come tomorrow.
No,
Will come now.
Oh, okay, sorry. Okay, online, no, online. Yeah.
So I'll start getting from tomorrow.
Hmm.
So I'll start with word detector tomorrow. So that's the base point.
Hmm.
Block merger, it will take time.
Hmm.
So it's a big process and there are a lot of things to do. So briefly, I've explained these three when the optimization started.
Hmm.
So they know briefly the block merger side.
Hmm.
So complete code and in depth, why exactly we are doing that. So we'll do after this digitization for this time. From tomorrow, I'll start with the document digitization. Word editor is the first step. So I'll start.
Are you doing the translator thing tomorrow?
No, I'll tell you because first I want to verify your documents. Okay. So you start with your documents. Tomorrow we'll do translator, but translator I want to do it like this on board. Okay. Tomorrow,
You're coming tomorrow? Then
no, I'm not coming tomorrow. We'll come probably sometime next week for translator. Okay,
Oh,
tomorrow.
so we have time for.
Yeah, that's what.
recording this.
That's what. Now these three modules are done. I want to see how you guys will come up with the document, right? Once we establish this process, then it becomes easy for next modules. So I don't have to review it every time. So your two documents and your workflow manager
Video
document.
also will be easy.
Yeah. So once you make and send it to me, and then we'll have. So now we have like a standard template, right? How we are documenting. Then after that, you can just keep on doing your documentation. I don't have to spend a lot of time. Okay.
That's what you like. When you're focusing on making this document.